What causes nuisance tripping in electrical protection schemes? Imagine flipping a switch and suddenly losing power, even though there's no clear reason for a fault. That's what nuisance tripping is all about. It happens when protective devices like circuit breakers or ground fault circuit interrupters trip without a real problem. It can be frustrating, especially in power systems and renewable energy setups where reliability is key. So, what causes these unwanted trips? Let's break it down. One common cause is overloaded circuits. When too many devices draw more current than a circuit is rated for, the protective device may trip repeatedly. Even if the overload is brief or slight, it can still trigger the breaker. This is especially true in power distribution systems where multiple appliances share a single circuit. Ground faults and leakage currents are another culprit. Ground fault circuit interrupters trip when they detect small leakage currents to the ground. Sometimes, transient surges or voltage spikes can cause tiny leakage currents that falsely activate these devices. Wet connections, long extension cords, or high-voltage nearby lines can also increase leakage, leading to unnecessary trips. Short circuits or wiring issues can cause similar problems. Damaged or loose wiring can create intermittent short circuits or electrical arcs. Arc fault circuit breakers are designed to prevent fires by detecting arcs, but they can sometimes mistake harmless electrical noise or minor wiring conditions for dangerous arcs. Corroded connections or loose contacts can generate heat, which then trips the breaker. As electrical devices age, their sensitivity can change. Older electromechanical circuit breakers use components like bimetal strips and electromagnets to sense faults. Over time, springs weaken, contacts corrode, and the bimetallic parts degrade. This can make the breaker overly sensitive, causing it to trip without a real issue. Installation and environmental factors also play a role. Improper installation, such as placing ground fault interrupters to or from the protected equipment or stacking multiple devices in series, can cause false trips. Moisture, rain, or water sprays can create leakage currents that trip protective devices unexpectedly. Transient electrical events are another factor. Sudden voltage or current surges from switching operations, lightning strikes, or motor starts can cause brief spikes that exceed the trip threshold. These short-lived surges can trigger nuisance trips, especially if protective devices are very sensitive. In power distribution and protection systems, nuisance tripping can cause unnecessary power outages, affecting sensitive equipment and reducing system reliability. To prevent this, engineers carefully select and maintain protective devices, ensure proper wiring and grounding, and minimize interference from transient surges. Using surge protectors can also help shield electronic trip units from voltage spikes. In essence, nuisance tripping happens because of a mix of electrical noise, wiring conditions, device aging, environmental influences, and installation issues. Understanding these causes helps engineers design more reliable systems and keeps power flowing smoothly without unwanted interruptions.